matrix multiplication. Most of you saw yesterday when you could multiply them. And they don't have to be the same size, but they do have to be compatible. And compatible ones, like A times B, these ones multiply together because those middle numbers matched up. And B times C, we noticed they were able to multiply together because those middle numbers matched up. But when I tried to do Kaka yesterday, the CA would work because that's a 3 by 2 times a 2 by 3. C and A work. But then when I get to CA, oh, maybe Kaka works. Oh, okay. Maybe Kaka does work.
Kaka's a lie.
Kaka's a lie. We said it didn't work, but I think it does. Okay. So the middle numbers have to be the same. That makes them compatible. And then the answer that you get, the size of the answer is the outside numbers. Now back it up. There you go. There we go. So if you did a 3 by 2 times a 2 by 5, you would get a 3 by 5. If you tried a 3 by 2 by 2 by 3, you would get a 3 by 3. Again, the middle numbers match up. That makes them compatible. The size of the answer is the outside numbers. But then how do we get the answers within? Okay, so here, rule number 1, the middle dimensions must equal. If those middle dimensions equal, then your answer is going to be a 3 by 1. They are compatible. It is so nice to get a matrix multiplication question where they don't match in the middle, because then it's the easiest thing in the world. Just like, yes, not possible, and you're done. Can we have a quiz with everything on that? Oh, speaking of quizzes, we are going to have a tiny quiz tomorrow. What? Tell your friends or don't.
Nah, we're not doing that.
Just on definitions.
No one tell Drew. No one tell Drew.
Where is this tree?
He's in Minnesota.
And you're going to be working with a partner, so you can choose your partner here, or you can choose someone who's
No one partner with you. Make sure that you're the
No, I'm not allowed to be part of this.
If
Okay,
there's an odd number
Oh,
of people,
so
wow.
mini quiz tomorrow, just on the definitions.
how many points?
I don't know, it'll be worth like 5 or 10. Something little.
About six.
Something little.
Can you make it out of 100? An open book.
1,000 points.
Yeah!
An open book.
It's not open book.
Keep 1,000-point open book quiz.
So this would be super nice to do because you look at it and go, uh-oh, those numbers in the middle don't match. So these are not compatible. It is not possible. Rule 2. Well, we've already talked about this, but if we can multiply them, then the answer will be the outside numbers. So yes, I can multiply these because the numbers on the inside are the same. The answer is a 3 by 1, the outside numbers. So in each of these examples, in this example here, you've got the answer there. Now, rule number 3, to get the answer, we multiply a row by a column and add. This is where things. So, to get the 23, and I'm going to color code this for you. This is what I do. You multiply, because matrices rock, so rows first, columns, that happens in multiplication too. To get this one, this is the answer matrix M, so this would be little m11. To get m11, you need to take row 1 and column 1. And actually what I do with this, I have a visual. So there's my column 1. My row 1, it actually comes along, turns, and crashes into these numbers. So that 1, 2, do you see I sort of turned it 90 degrees, crashed into those numbers, sending the 1 times 7 is 7 and 2 times 8 is 16, sending those numbers all over the place. And you have to pick up the pieces and put them together, and the 7 plus 16 makes the 23. That's my visual. So I'm like, oh, I'm multiplying here. And then I pick up the pieces and add them together.
Is that why it only works when you have the middle?
That's why it only works if the middle numbers be the same, because I need the columns to match up with the rows so that when they crash, everybody has something to crash into. Nobody feels left out and survives. That's good. So then, that is how, in green, I would get this 23. Then in purple here, this is row 2, M21. So I would take row 2 and column 1. And now my 3, 4 turns on its side, crashes into the 7, 8. 21 over here, 28 down there.
4 times 8.
32, yeah, that's good. That's good. Just seeing if you're awake. I saw, yeah, I think I saw the 4 and the 7 again there. And we add those together, pick up the pieces, and you would get 53. And finally, I'll do this last one in blue. Right, this is M31, so I take row 3, column 1. So when you know how big your answer is, and you're trying to find a specific spot, if you label that part in your matrix, you can be like, oh, I have to take, this one's small, right? But if your answer was a 3 by 3 and you're finding a bottom one in the middle, you're like, well, which one do I do? Oh, I need to take this row and this column, crash them together and see what I get. So when I do this, turn this on its side, 5, 6, crash it in to the 7, 8, 35 and 48, pick up those people. Oh, that is the ugliest 8 I've ever seen.
Oh,
It crashed hard. It makes sense. There was like a little bit injury. But you add those two up and you get 83. And this is the rule for how matrix multiplication works. But if you just got this example and said, figure it out, the 23, 53, and 83 would be like, how the heck? Right? It's kind of really hidden how you get that answer. So the first thing I would do when I'm multiplying, and I'm multiplying by hand, I'd be like, okay, are they compatible? Yes. Then how big is my answer? 1 by 2. And then I would look at each element to figure out which row needs to multiply by which column, crash them together, add up the pieces. So, now we can do these ones on page 10. We could do them by hand. You've got the answers already. But if I multiplied A times B, A, always good to write your dimensions, 2 rows, 2 columns. B, 2 rows, 3 columns. So I would know that my answer is going to be a 2 by 3. if I wanted to find this one right here, this is row 1, column 1. So I would take 1, 0, turn it on its side, crash it into the 2, 2. 1 times 2 is 2. 0 times 2 would be 0. Pick up the pieces and you would get just 2 there. Does that make sense? I'm going to figure out this bottom one right here. All right? You see that that's row 2, column 2. That's the position of that element. So I'm going to just look at row 2, column 2. Turn and crash them together. Pick up the pieces. Can you see that you're going to get -2? Perfect. So you don't have to figure these out in order. People like to do them in order, but you can be like, oh, I want to, here, I'll erase the blue, right? I want to figure out this one next in red. Well, that's row 1, column 3. So I would need row 1, column 3. Turn row 1, crash it in there, pick up the pieces. Mental math, and you see you're going to get -1. Because 1 times -1 would be -1. 0 times 3 would be 0. 0 times -3. So we can figure out all of those answers just by taking the rows and the columns, crashing them together, and figuring things out. Now, some of you already took page 10, and with your calculator, you have these answers in there. So you know what the answers are, you wrote them down. If you want, you can now double check some of your answers by taking the rows and crashing them into the columns. So instead of writing these all down, because you should have them already from yesterday's activity, we'll just pick one spot to do. So for example, this is 2 rows, 3 columns. This is 3 columns, 2 rows. My answer, I'm not going to make appear, is going to be a 2 by 2. I'm going to figure out this spot right here. That's row 1, column 2. So I take row 1, column 2. I turn row 1 and crash it in. When I do that, 2 times -1, that would be -2. -1 times 2, that would be -2. And -1 times 4, that would be -4. When it crashes in, pick up your pieces. This number here, once I add up all those pieces, needs to be a -8. So again, for me, I visualize taking this. I like wind it up and pull it back. And as I pull it back, it's like spring loaded till it gets to be turned, and then I let it go, boom, crashes into that. Pick up the pieces. It's -8. Oh, there it is. Perfect. And you could figure out the other ones as well. Okay. So we're going to skip ahead here. If you really want, oh, this could be disastrous. Here, now they all appear. I'm going to make them appear so if you didn't do this in class the other day and have these answers written down, they'll be on the video. Yay, it doesn't work. They'll be on the video. So you can check your answers later. One more. There. And unlike regular math, A times B is not the same as B times A in matrices. And as you get into bigger levels of math, you look at all of the regular rules of math and see which ones apply and which ones don't. So the word commutative is the fancy mathematical word that says 5 times 3 is the same as 3 times 5. Right? And you've known this for a long time. You probably don't even remember when you learned this. But as a math person, because you are in AP Calculus, whether you like it or not, you are a math person. You are in the top echelon of math people in the world. Okay? But if you have a little cousin or even someone who's just learning how to add, subtract, multiply, divide, is super fun. Ask them 5 plus 3, and they'll take a while. You have to be patient. Probably whip out the fingers and everything, right? And they get 8, and they're like, oh, you praise them, like, good job, good job. Then right after say, okay, what's 3 plus 5? And it's really fascinating because you know that 5 plus 3 and 3 plus 5, that's the same question. In your mind, it's the same question because you know that they're equal to each other. But it's super cool to see that that kids don't know that yet. But we'll bump the fingers again, like, oh, this time I'm starting with 3. And it's just, and you can check it with multiplication. You can do, someday you're gonna have your own kids, you can do all sorts of mathematical experiments on it. And see when they learn things and when they don't. So here are, wait for it, maybe. Here we go. The laws of matrix multiplication. Number 1 is not true. A times B is not B times A. Okay. A times A only works if it's a square matrix. Doesn't always work. But A times B times C is the same as A times B times C. This is the associative property in mathematics. That it doesn't matter, right? When you do 2 times 3 times, I'm going to put 5 in there. Okay. You could do the 2 times 3 first and get 6, and then go 6 times 5 and get 15. Or you could do the 3 times 5 first and get 15, and then times by 2 and get 30. And in regular numbers, you could even do the 5 times 2 first and get 10, and then multiply by 3. But in matrices, you would not be able to do the C times A first and then the B last, because that would be rearranging, and switching things around and rearranging is not allowed. Okay? You can distribute. But now that you've seen matrix multiplication and how crashy it is and complicated it is, and you saw matrix addition, which I had forgot how to do, but Kane nicely explained for us, right? Which was brilliant. Why would you want to multiply twice and then add when you could just add them together and only have to multiply once? But distribution exists there. And then for your definition quiz tomorrow, shouldn't show up late. All that information you're gonna have to find out. For your distribution quiz tomorrow, you're gonna need to know what's an identity matrix? What's a transpose? What's there's not that many definitions, but you do need to know them all. But this is where the identity matrix comes into play. The identity matrix is like the number 1. So when you multiply by 1, you get what you started with. And if you multiply by 1 in front, you get what you started with. So if I took a 3 by 2, 1, 2, 3, 4, 5, 6. If I'm going to multiply it by something to be compatible, it's got to be a 2 by something, right? And identity matrices are always square matrices. So here's my identity matrix. And my answer is the outside is going to be a 3 by 2. Now look what happens. Column 1, row 1. Turn, crash. Well, the 2 doesn't matter because it hits a 0. And the other one's 1 times 1. It's going to be, whoops, not sure it's 1. Next, purple. This one, row 1, column 2. Wind it back, turn it back, crash into it. You're going to get a 2. And if we kept going, 3, 4, 5, 6, it's going to end up being exactly the same. So the identity matrix is really important that way. I could have put a 3 by 3 identity matrix out in front and crashed those ones all in there. And it would still turn out to be the same. So there's the number in matrices. There exists a number 1. In higher level mathematics, things that act like the number 1 that we're used to in regular numbers is called the identity. Number 1 is the identity. And in matrices, there's an inverse, where if you multiply by the inverse, it gets you the identity matrix, and things go the same. Oh, I don't know why I had 1/3 times 1 is 1. That's good for you. All right. So these are our laws, and we're going to be using them. But stop this video here.